my name is Varshit, and now we are going to discuss the topic dead programs. Well, to overcome some of the flaws of Wheeler Jump, the Van Poel proposed implementing a push-down stack in writable memory for subroutine calls. For Terra, regular memory, which means a magnetic drum memory, and which also means a magnetic drum memory. Van der Poel described this method in December 1952 in an article with the mysterious title Dead Programs for a Magnetic Drum Automatic. And in the dead programs were programs stored in write only memory. And Van der Poel wrote that to project program code. And Terra letters uses block write access to parts of the drum. And using a small plug board, the term dead came back also in reference to the plug board itself as providing dead register. The program couldn't modify it, and although the function can call stack seems to us like the obvious way to implement function calls, it wasn't immediately picked up as a right method. This is clear from Dikshitra PhD thesis, which appeared 7 years after van der Poel's article was published, but still described the older method. Happily, some of article was published, but still describe the older method, and the pioneers are still among us. But as the discipline matters, their numbers are dwindling. I consider myself lucky that I could learn my trade from one of them. Even though I didn't realize it at the time, William van der Poel, now 90 years old, and continues to work as he always has. It's just that the computer he uses are a bit faster than once he started working on almost three quarters of a century by about 11 orders of magnitude. That is, computer science is young enough as a discipline that we can still talk to some of its pioneers. It's astonishing to realize how recently some of the key developments really took place. And as an example, I'll look to the mechanism that used pretty much universally and today to implement function calls with a stack using push and pop operations, or we call instructions, to modify its contents. The stack stores parameters for the call and, most important, the return address, so that you know where the execution should resume after the function completes. While you adding the strings or values to the stack or queue, it means if you stop the contents, you can need to resume after the function completes. A stack might seem the obvious data structure to handle this. How else could you support nested calls? But somebody had to be first to figure that out. The prehistory. When I say that computer science is young, I mean that the first practical general purpose computers were constructed less than a lifetime ago. The construction of more specialized devices for performing specific tasks of calculation has, of course, a much longer history. The oldest known example is probably the Antikythera mechanism, which should predict the timing of solar eclipses. It originated in the 2nd century BC. The first serious attempt to construct a general purpose computer was by Charles Babbage. He first described the design for his analytical engine in 1837, but the challenges of actually creating a working machine with the then available technology were overwhelming. When the computer science is young, he means that first practical general purpose computers was constructed less than a lifetime ago. The construction of more specialized devices for performing specific tasks, which means the specific task can be performed by a specific devices, and it is probably the Ankythera mechanism, which could predict the timing of solar eclipse, which is the highest technology at that time, and it is the first serious attempt to construct a general purpose computer by Charles Babbage. He first described the design for his analytical engine at the year of 1837. But the challenges of actually creating working machine with the technology were overwhelming. Already at the time of Babbage, a better understanding of electricity and magnetism started emerging. Recently, the Charles Babbage creating the general purpose computers. At that time, electricity was started emerging, and especially after Hans Christian Ørsted discovered the link between the two in 1820. But these insights took another century to find their way into working computers. That development was clearly in the air in the 1930s when Alan Turing developed the theory of general purpose computing machines. At number of working computers existed yet, but that soon changed complete electromechanical computer to a contest. He had to settle for an honorable mention. It means, but these insights took another century for the working of the computers, and the clearly development was in the air in 1930s. The first relay machine. In the year 1930s, in Germany, Konrad Zuse designed and built one of the first electromechanical computers. Around the same time, in the US, Bell Labs researchers George Stibbles built a series of computing devices using electromechanical relays. Relays were used in all telephones switches at the time, so they weren't hard to get it. Relays were used in telephone switches so that they can buy easily and at the cheap cost, so they weren't hard to get. Similarly, vacuum tubes for amplifying signals were readily available, and the vacuum tube for at the time is very very rarely not we can see, and we can see like cheap also. And about in 1944 in the Netherlands, 18-year-old William van der Poel, about whom you will hear more shortly, also started designing relay computers. A few years later, a student of Delft University, he submitted the design complete electromechanical computer to a contest. He had to settle for an honorable mention. A key step in the development came in 1945 with the construction of EDVAC, and EDVAC stands for Electronic Discrete Variable Automatic Computer. And EDVAC introduced the familiar non-Neumann architecture, in which programs were stored like data in the main memory of a machine rather than being hardwired on plug boards. George Dyson book Turing's Cathedral offers a fascinating description of these early developments. After graduating, van der Poel joined PPT, the Dutch telephone services provider at that time, which was of course an excellent place to get access to large number of telephone relays. He worked with the Leonard Kosten on designing and constructing a series of computers that were based directly on the von Neumann architecture, and it is the one of the first of those machines was Terra, and PTT Electronics Reticonomat or PPT Electronic Computation Automation, which went into operation in the year 1953, and the Testudo and Terra. With the news of Edward spreading, Vanderpoel got a chance to help build with the first Dutch computer in the year 1947 to help the Delft University Optics Group, and it automates its calculation. The machine became the subject of his master's thesis 3 years later. The machine, nicknamed Testudo, is Latin for tortoise, or took 30 seconds for an addition and 45 seconds for a multiplication. But it was used for many years because it could work tirelessly through the night to perform its calculations. This is merely an extension to cascading updates on foreign keys. And in fact, data duplication has many benefits. In a relational database, if you don't duplicate, the item will be lined up. and it will be price should be increased, and it can perform tirelessly through the night to perform its calculations. Thank you.